All right, page 17. So now let's investigate what happens when you divide powers with like bases. So with the same bases we have, what happens if we divide the powers? So it says write each numerator and denominator as a product, and then simplify each expression and write the simplified expression using exponents. So first we have 9 to the 5th power divided by 9 to the 2nd power. So we're going to write the numerator as 9 times 9 times 9 times 9 times 9 because it's 9 is being raised to the 5th power, divided by or all over 9 squared. So we can say that it's going to be 9 over 9 squared, so it's 9 times 9. And we can say that we're going to we're going to simplify these by the number of 9s we have. So to show you guys, it's going to look like this. So the 9s are canceled. So this right here, we can cross the 9s. And same thing, the 1 9 on the bottom, 1 on the top. So on the numerator, we're only left with 3 9s. So with using an exponent, we can say the answer would be 9 to the 3rd power. Okay, so 9 to the 5th power over 9 to the 2nd power, or 9 to the 5th divided by 9 to the 2nd, is same thing as 9 to the 3rd power. So let's move on to letter B. It's 5 to the 6th power over 5 to the 3rd power. So on the top, we write 5 to the 6th, so 5 times 5 times 5 times 5 times 5 for 6 times, over 5 times 5 times 5, like this. And we can simplify this, cancel these out, cancel these out, cancel these out. So we can cancel 3 pairs of 5, and we're left with 3 5s on the numerator. So we can say that it's 5 to the 3rd power. For C, it's a little longer, so I'm going to have it on the side right here. 10 to the 8th power, we write the 10 8 times. Over 10 to the 6th power, we write the 10 6 times. And we can cancel 1, 2, 3, 4, 5, 6 pairs of 10s. So we're left with 2 pairs of 10 as a numerator. So we can say 10 squared is our answer. For D is 10 squared over 10, meaning 10 times 10 over 10, which we can cancel 1 pair of 10, and we're left with 10. So it's just 10 to the 1st power, or same thing as 10. So what relationship do you notice between the exponents in the numerator and denominator and the exponents in the simplified expression? So we can say that the exponent in the simplified expression is a difference in the exponents in the numerator and denominator. So let's look back. So 9 to the 5th over 9 to the 2nd. The answer, the simplified version was 9 to the 3rd. Notice how it's basically the difference of 5 and 2. So 5 minus 2 gives you 3. Same thing, 6 minus 3 gives you 3. Same thing here, 8 minus 6 gives you 2. Here, same thing, 2 minus 1. Notice how there's an imaginary 1 here, right? So 2 minus 1 is 1. So the rule that we can say would be when dividing with powers, keep the base and subtract the exponent in the denominator from the exponent in the numerator. So mathematically, it'll be like this, where a is the base, so a to the m power over a to the n power. So they must have the same base, okay? And you would get the same base, but the exponents would be m, the numerator exponent, minus the denominator exponent. So that would be the simplified version. So let's do some more practice here. Number 4, simplify each expression using the rule that you wrote for a quotient of power. So quotient is the answer to a division. So it says 6 to the 8th power divided by 6 to the 3rd power. So we take this rule, we have the same base, which is 6, so 6, and 8 minus 3, right? So 8 minus 3 is 5, so it's 6 to the 5th power. Same thing here. Notice how there is negative out in the front, so we're going to have to put a negative out in the front. And 9 is the same base, so it's 9, and 7 minus 5, which is 2. So negative 9 with the 7 minus 5 as an exponent, we get negative 9 squared. And letter C, 2 to the third power divided by 3 to the second power. This would not be possible to simplify because 2 and 3 are not the same. They don't have the same base. So if that's the case, we can't simplify further. Okay, the bases have to be the same in order for us to simplify like this.